It is best to leave that question unanswered, but intuitively, one may perceive it as the branch of mathematics that studies the properties of space and its contents. In its primitive form, geometry provides us means to visualize various mathematical relationships. There are several types of geometries. We are about to study the most basic form of geometry that is known as Euclidean geometry, which was the predominant type of geometry till the dawn of the 19th century. It all began when Euclid, a Greek mathematician living in Alexandria, Egypt around 300 BC, decided to come up with a collection of 13 books which included probably all of mathematical knowledge known to the Greeks during the period that he lived. The set of the 13 books, known as Elements, was instrumental to the development of mathematics not because it unified all of mathematical knowledge of that era, but because the way that knowledge was presented. Like a builder who first constructs a solid unshakable foundation before going to lay brick by brick to construct a building, Euclid starts from the simplest of facts, and through logical reasoning he goes on to build more complex mathematical material. A mathematical discipline constructed in this fashion is known as an axiomatic system. An axiomatic system typically has four main components: undefined terms, defined terms, axioms, and theorems. Undefined terms are used to construct defined terms. Defined terms are then used to construct axioms, and axioms are used to construct theorems. Once simple theorems are constructed, they are used to construct more complex theorems. Undefined terms are terms whose meaning cannot be explained clearly. For example, take the term love. You can say what you do or what you feel when you are in love, but can you clearly define what love is? In mathematics, we leave certain terms undefined because such definitions might ignite controversy. A good example is the term a set, which is intuitively perceived as a collection of objects. In set theory, the term a set is left undefined to avoid logical obstacles. Defined terms are terms whose meaning can be clearly explained using undefined terms. For example, in set theory, though we avoid defining the term a set, we define the term null set as the set that has no elements. Using defined terms, one can construct statements which are accepted to be true within the mathematical community without any controversy or doubt. Such statements are called axioms. For example, here are three axioms regarding the set of natural numbers. The three axioms are trying to tell us what numbers must be included in the set of natural numbers. The first axiom says 0 is a natural number, which states the fact that 0 must be included in the set of natural numbers. The second axiom states that if n is any natural number, then its successor n plus 1 is also a natural number. The third axiom says that 0 is not the successor of any natural number, which states the fact that 0 is the least member of the set of natural numbers. So you can see that these three axioms tell us that the set of natural numbers includes number 0 and all the counting numbers starting from number 1 up to infinity. These three statements need no proof. They are well accepted within the mathematical community. That is why they are called axioms. While axioms represent known knowledge, theorems represent discovered knowledge, the knowledge that is derived from already known widely accepted knowledge. Unlike axioms, theorems need proof, which means you need to show how the theorem is derived from axioms and more simpler theorems. If Euclid's elements never existed, it is highly likely that we would still be in the Dark Ages. Euclid's work was the first love of many geniuses throughout the history of mankind. The two of the best examples being both Newton and Einstein. There are some narrow-minded, maybe not so intelligent people who think that Euclidean geometry is of little importance in the modern world. But studying Euclidean geometry will give you three benefits. The first one is you will learn the nature of an axiomatic system. The second is you will have a wonderful opportunity to practice logical reasoning. The third benefit is you will learn new theorems that would help you to solve certain problems in trigonometry. Okay, so let us study Euclidean geometry.